For our project, we did a Tetris game. The way it starts is there's a coin slot, and we have a photocell that's mounted opposite of an LED light, and when the coin passes through, it detects the darkness and starts the game. And then we have these two buttons. This one increases the speed that the blocks are dropped, and then this one rotates each shape, and then we have a two-way joystick which moves shapes back and forth. And then we have a ticket slot at the end of each game. The score is scrolled across, and then that corresponds to a runtime of a DC motor, which will print out an X number of tickets. And demonstrate the game. Let's put the coin in. And I'll start, so I'll show the back and front of the joystick. And then this increases the drop speed. And then there's a buzzer that sounds every time the shape reaches its resting spot. And then also at the end of each game. So we can speed it up now. Alright, so once the game is over, the score scrolls, and tickets are printed.
The display itself is a few SparkFun LED matrices glued together. The rows are hooked into transistors that are connected to the PIC F887, and then the columns are hooked into 330 ohm resistor array. And then basically, in order to turn on an individual pixel, it lights up a row and a column at the same time, and then that one LED light turns on. In order to show complex shapes like the Tetris blocks, it'll turn on one light at a time, and because it's running at 8 megahertz, that happens faster than the human eye can, and so it consolidates all those individual blinking lights into a full image.